Page 7 in your book. Yeah, I know, that's a tough one. Let's actually on page 6, take a look. Definition of relation, domain, and range. Now, you have a book. You do not have to write this stuff down. You can take notes as you want to take notes, but you don't have to sit and write everything down, especially if you have it in the book. What? No. No. But the test will be more analytical. They're not going to be memory, like memorizing a definition. All right. You know, what's that? Alg 1. There's a lot of Alg 1 in this. There's even some geometry. There's some Alg 2 in it. Yeah, but see, you'll like this because it's a combination of all of them. But. All right, definition of relation, domain, and range. A relation is a set of ordered pairs. What are ordered pairs? Remember the X, Y? X, Y, ordered pairs. So we could have 1, 2, and another one would be 3, 7. This could be an ordered pair, right? They're points on a graph. They're points, and then we recognize that by X and Y. Okay? The domain is a set of all, what is that? A bisecus? Success? Yeah, of the ordered pairs. In other words, what contains all these? If we were to draw a line, and one point would be here and one point would be here, this domain right here would be the domain of those ordered pairs. All right? The range is a set of all ordinates of the ordered pairs. So what's the range of this? It goes from this point here to this point here. There's your range. All right? That's just to help you that some definitions we'll go through. You going to write all this down? Oh, okay, just checking. I'm thinking she will. All right, page 7, a function. A function is, well, you know, until you get into the hang of how we're doing this. A function is a relation in which each element of the domain is paired with exactly one element of the range. Okay, I've got my domain, right? Here's my domain right here. My range is in here, so exactly one element. So I could put a point right here, and I could say, yes, that point is within a domain and range. A function, if you take a look down at the bottom, they've got that parabola that's pointing out to the left on page 7. A function can also be defined as a set of ordered pairs in which no two pairs have the same element. All right, and if you take a look at that parabola, you could take a look at points on that red line. It's within that range, but it doesn't have the same element, same first element. All right, that's about all I'm going to say on that stuff. Graphing. Oh, here's what I hate. This never works for me. Oh, it did. Whew. Actually, I've got an easier way to do that, too. If you take a look on page 8, each element of domain is paired with exactly one element in the range. Therefore, the graph does represent a function. All right? If you take a look at A, each element of the domain is paired with exactly one element of the range. Therefore, a graph does represent a function. In B, a vertical line would pass through vertically, or would pass through indefinitely, many points of the graph. Therefore, the graph does not represent a function. So if you look at those two graphs, we have just single points on the graph. That represents a function. But if we have something that's continuously, in other words, never ending, that is not. You guys get a little bit understanding how that works? Good, cool. I'm going to let you guys go from there. Take a look at example 3. We have function of 3, or f of x equals 4x squared minus 2x plus 5. If we put 3 to this, we come up with a definite point. Would that be a function? Yes, that's a function. We come up with a defined point. All right. How about for the next one? F of x equals absolute value of negative 3x plus 8. Is that a defined point? No, because you could have two different x's, right? And come up with two different, or you come up with the same value. All right. I'm going to skip on to, and actually, guys, this is about all we're going to talk about in here. You can take a look at example 6. That deals with a different type of function. And now we're going to do some problems. Yeah. And what it is, you take a look at, and I'm going to give you, and I'm going to give you half a dozen problems when I do this. All right. Take a look at 19, 21, 23, and I want you to take a look at where are we at down here? No, let's do it this way. Let's do 27, 29, and 31. 27. Oh, give me a pen. 27, 29, 31, because you can get the answers in back for these. Keep it in your notebook right now. I want you to do 33, 37, and I'm going to do 43. 33, 37, and 43. 6 problems, right? 6 problems. Guys, this is how I'm typically going to do it. It isn't going to be a lot. When we get into heavier stuff, what's that? Right in your notebook. Yeah, you want to keep this